I mentioned hub and spoke architecture, which I said is important. There are a few different people that supply data warehouse appliances on the market, and many of those are really aimed at the, well, most of those actually are aimed at the centralized data warehouse market. So you buy the appliance, it maybe contains some proprietary components. I say proprietary meaning specific hardware in this particular case, generated by the company. You have to go and buy it from that company, and it really well, it focuses on loading all of your enterprise data, or a large volume of enterprise data, into the centralized appliance, which is then accessed by different systems through a query interface. What we normally experience in an organization is that different business units need to run at different speeds. So I might have one business unit that needs to develop a regional reporting solution, another which needs to generate a departmental reporting solution, another one which is looking at headquarters reporting. I'm reading this diagram here. And all of those share some information, but they're running at different development speeds, and they're running with different processes, different teams. But what is absolutely common is that we want to enable a way for us to build our corporate data warehouse such that we're sharing concepts, so we're conforming concepts so that we're getting consistent views of customers, consistent views of sales, consistent views of financial data, whatever it might be, in these different areas, in these different business units if that's required, but enabling that in such a way that it's easy to manage, and that it doesn't mean different teams going out and developing different extract, transformation and load processes, each of which might do it in a slightly different way. It doesn't mean taking account of the vagaries of our network and the different speeds or different latency that we have in our network. So what we want is a way of gathering, quickly getting data loaded into our central data warehouse, enable us to build that core data warehouse, but distribute it very easily and very quickly out to the different business units that need to consume that information, and perhaps add to it and augment it to deliver their departmental or regional reporting solutions. So Microsoft's PDW enables that by specifically supporting the idea of a hub and spoke architecture, and that you have a centralized hub which publishes information to different spokes via a dedicated high-speed network, which is giving you kind of, what is it, 500 gigs per second, I think is, if I remember the rating, the normal kind of rating. The publish and subscribe method is therefore managed in the tool itself, where you can say, this particular spoke is subscribing to these particular tables or these particular sets of data, and the distribution of data and updating of data is managed centrally by the hub itself. So it's separating the whole process of managing the distribution of enterprise data out to the different spokes, and making sure that's consistent and making sure that happens quickly, from the processes involved in developing regional reporting or specific reporting requirements for departmental needs in response to a business unit. The people who are involved in both the fast track data warehouse and the parallel data warehouse are Bull, Dell, EMC, HP, and IBM. From all these people, you can go out and buy a solution. The idea is that it's an appliance experience. You go straight to there and you say, I'd like to buy, a parallel data warehouse appliance. You choose your vendor, choose what size of appliance that you're interested in, and there's different drive size and configurations depending on the, the capacity that you need. And then, and that will obviously then dictate the number of racks that you'll purchase. And the hardware vendor will assemble all the appliances, pre-image them with all the required operating systems, SQL Server and software, and install that. And then Microsoft's going to provide support for that, and hardware vendor on the actual hardware support. So we've got software support and hardware support from the vendors themselves. So, for example, if you're going to HP, fast track data warehouse, as I mentioned, you might go from 6 terabytes up to 48 terabytes with Hewlett Packard, going from basic, mainstream, up to premium. So these are pre-configured machines, going from a DL385 series up to a 780G6 series with their storage array pre-configured. So, this is kind of a way of purchasing a large-scale SMP system for various different data warehouse needs. And then if you go into PDW, you're moving into a slightly different model, of course. You're now into a MPP system, so That's organized as a control rack where you have the management server and the control nodes, which are responsible for the distribution of workload, and then you have your compute nodes, which are responsible for the execution of query workload in parallel. So the compute node itself is, of course, a database server, so that's a specific server running SQL Server 2008 and Windows Server attached to its own dedicated storage node. And those are all connected via the compute node is connected via fiber channel and then connected to the storage node with dual InfiniBand. So you have key features of that architecture are active passive failover on all control nodes, so redundancy in that area. Also redundancy in the data rack by having a n+1 failover, so you have n compute nodes in the data rack plus 1 as a failover should any one of those fail. So everything, and of course all the drives are mirrored, so everything in the system is fully redundant and pre-configured for automatic failover. The number of data racks that you have is entirely dependent on the volume that you would purchase. So whether it's a 10 terabyte system or a 100 terabyte system, you would purchase a number of data racks corresponding to the volume. Each data rack, depending on the vendor, would contain between 8 and 10 different compute nodes, which, as I said, comprises the database server and the storage node. As you would also have seen on there was also a couple of other servers included in the control rack, which is the backup server, which is a dedicated server that's providing backup capability, and also the landing zone, which is a dedicated area that's available both on the public and on the private internet of the appliance, which is a staging server for ETL processes. So for example, if you're loading data in from external systems, be it files or other database systems or ERP systems, you're connecting that to the landing zone and landing your data there from where it picks up, from where the PDW picks that up on its high-speed network, and it loads that into the data warehouse using dedicated processes such as DW Loader. So there are specific utilities in there to do high-speed data loading into the appliance itself. Key to how the appliance works is the concept of distributed and replicated tables. So we'll just touch on this in very much in brief, because we're not going to go in this in detail on how you optimize for this, but it's kind of important to how it works, I think. So how does it work? How can you possibly get a query that's distributed equally and satisfactorily across 40 or however many different nodes in my data rack? As you know from your own activities around developing data warehouses, if you develop using dimensional modeling techniques, you might arrive at a database schema which is called a star schema, which is where you have multiple dimension tables which describe a central fact table. So I have dimension tables such as customer, item, promotion, store, which are describing the central fact table, which is where all, in this case perhaps my sales data, is sitting. If I query if I made a query that said get me the data for stores 1, 2, 3 and 4, the sum of the sales data for stores 1, 2, 3 and 4, Parallel Data Warehouse can execute that in parallel by identifying that actually what I've done is I have partitioned my fact table by store, and I have identified that as a distributed table in PDW, which means that the data has been set into partitions and distributed across the different compute nodes in my data rack. I have also said that commonly when I'm identifying those fact records, I'm placing predicates on these different dimension tables. These are pretty small tables, typically less than 1 gigabyte. It makes sense to replicate those tables on all the different nodes so that they're everything that's needed to place a predicate on the fact table for a specific store is available within one node, and I don't need to move data around to satisfy a particular query. So now if I said get my data from queries 1, 2, 3 and 4, the control node can correctly identify that I have a query that's going to span 4 different partitions. It can identify the different compute nodes that are required to satisfy that query, and it will send a query to each of those different compute nodes, which will be executed independently and in parallel on those compute nodes, and the results returned to the control node for aggregation and returned back to the client. So core to the way PDW works is this idea of distributed and replicated tables. So that enables us to get to, of course, incredibly large-scale data warehouse, as is an example with First Premier Bank Card. First Premier Bank Card, of course, is a common reference used by Microsoft because it's a very, very good customer adopting leading-edge Microsoft business intelligence technologies. You go back SQL Server 2005, 2008, and now PDW. First Premier Bank Card has been leading the way in implementing Microsoft technologies. For this particular environment, implemented the current data warehouse on PDW, identified more than 100% improvement in data load, 200% improvement in query response speed, and proven that they can implement a large number of concurrent users. And numbers of users in First Premier Bank Card goes into the thousands of users, and actually lowered their cost of ownership where they were previously massively scaling up SMP systems. Now implementing PDW, they've identified a number of savings through that. So one customer who's taken what was existing, SQL Server system, moved it to PDW, and identified a number of different tangible improvements, both in experience and in actual cost. So to summarize, SQL Server 2008 is a data warehousing platform that is available today. As I said, it has a number of different enhancements specifically to assist customers in deploying a data warehousing workload, such as can handle obviously multiple terabytes of data, and data compression, resource governor, policy-based admin, star optimization, merge support, and also the fast-track data warehouse, again available today, where you can take the guidance from a hardware vendor and from Microsoft as how to implement a large-scale SQL Server 2008 data warehouse on an SMP system, so scaling up hardware, and also now available the parallel data warehouse, where you need that very high-end scalability in data warehouse, where you want to enable a hub and spoke type architecture, publish and subscribe type mechanism, and you need you need to go up to that kind of petabyte level almost of storage. What we can then suggest as next steps, that's obviously a very brief introduction. It's difficult to do something like that justice in 20-30 minutes, especially when we have an unknown audience. What I would suggest is that you engage IMGroup in looking at your data warehouse vision, using something like the Vision and Foundation service from IMGroup, Information Management Group, looking at your business requirements for data warehousing, your objectives and goals, assessing the readiness of the organization for data warehousing, and identifying a roadmap, so stages where you might deploy or develop your data warehouse strategy and so on. And then looking at the different practices and capabilities in the organization, such as relational dimensional modeling, ETL, OLAP, and going into the client side. Obviously, that's then focused on your own individual requirements and can help you identify whether SQL Server 2008 is the right approach, perhaps fast-track data warehouse, perhaps going into PDW. And of course, if you go into PDW, there are specific skills and experience that are needed there to make sure that you take best advantage of that platform. What I'd suggest is that you can contact myself. My email is there, scottadams@imgroup.com. You can also contact Steve Procopio. He's in business development here, and his email is listed. I'd be happy to have a conversation with you about setting up a meeting or identifying what the appropriate next steps, or even if you just want to talk in more detail about the technologies, or send me an email asking some more detailed questions. I'd be more than happy to respond to that. Or if I can't, I'll bring some ex-colleagues from Microsoft who might be able to add more if it's a very specific question that's applicable to Microsoft. So thank you very much for attending. That's us at 30 minutes now. So I thought I was going to do it a little bit faster, but at least I ended on time. Thank you very much for attending, and I wish you a pleasant remainder of your day. Thank you.